Okay, the next speaker will be Jin from Saga. He's the co-founder, and he'll be presenting about the state of Web3 infrastructure and improving the developer onboarding experience. Okay.
Thank you. So how does this work? Oh, perfect. So hello, my name is Jin. I'm a co-founder at a project called Saga. I was kind of early in the days at Tendermint and Cosmos, so I've been in the app chain space for a very long time. And today I wanted to kind of show essentially a framework, what people can think about in terms of Web3 infrastructure and how developer journey should be thought about. So right now, Web3 infrastructure, I would say, is failing developers pretty hard. And a lot of people kind of talk about the problems that we have with Web3 infrastructure. But what specifically is going on here, right? So in this front, the developer demand, if you look at how people use infrastructure, it changes over time. So in this diagram, I've kind of shown testing, early adoption, and growth. And when they select different kinds of infrastructure, at different points in time, developers ask for different things. So in the very beginning stages, when you're testing and you don't really have customers, the biggest kind of criteria that people think about is is it really easy for me to start? Is it very quick, right? Then as they start getting small numbers of users, they think about, hey, is it really is it cheap to get started? Is it affordable? Then as they start getting more and more users, eventually they start thinking about, hey, is this technically scalable? Then finally they start thinking about, hey, is this economically scalable? And this is the journey that most developer kind of follows through with their adoption curve, essentially. So now, an effective infrastructure essentially goes through and it guides a developer from the very beginning, from the testing stages, all the way to the end where they're in the growth stage of needing to kind of scale rapidly, right? So what's going on? So if you kind of take a look at how early days of web was, I'm going to kind of analogize the situation and kind of bring it back into Web3. But back in the day, back in like 2000s, late 1990s, people kind of went to these web hosting solutions to host their applications, right? So there's GeoCities, WordPress, DreamHost, HostGators. These are kind of like new names, but they've kind of existed for a very long time. And the idea is people can kind of go and deploy very easily, and it was pretty affordable and easy to do so to get started. But as soon as they started reaching kind of real use cases, it started kind of failing a little bit, right? And so what did these people do? People like Netflix, people like YouTube, they actually went and built their own data centers. This is kind of the beginning stages of them trying to scale their product out ultimately. And in the beginning, it was, obviously it's technically scalable, it's economically scalable because you're building your own data center. But it's really hard to build a fucking data center, right? So it's difficult to deploy, it's not easy to get started. And the big thing about this is that there's this technology chasm. So essentially, you want your application to start up there in the hosting solution. And by the time you start getting users, you want to switch over to the data centers. But there's this giant gap that exists that makes it really difficult to jump over, right? And this is kind of the situation here today in Web3 right now. So if you take a look, people are deploying on monolithic chains like Solana, ETH, Polygon. It's easy to deploy, it's affordable when you don't have any users. But as soon as you start getting real users, it starts getting kind of untenable, both technically and economically. So what do? People go and say, hey, let's go and build an app chain. So it's kind of similar to building your own data center. It's pretty difficult to start, right? But it's technically scalable and economically scalable. And in Web3, we're kind of in this situation right now where people get started in a monolithic chain and they're like trying to kind of jump over into their app chain situation. And we saw DYDX and Axie Infinity try this. And it takes about a year, essentially, for them to transition from deploying on someone else's chain to kind of having your own app chain. It's a very long process, right? So what happened in Web 2, essentially? So what cloud did, essentially, is it removed this barrier by making it a service, essentially. So how do you do it? What do you do in AWS? With AWS, it's pretty easy to get started. It's affordable to get started because you pay as you go. And then as soon as you start getting some adoption, it's technically scalable because it's horizontally scalable. And then it's economically scalable because you pay as you go. So it's pretty linear in pricing ultimately. So what really the web, I guess, 1 to 2 revolution happened is there was an effective infrastructure, essentially, that could support a developer from the very beginning all the way to the very end, essentially. And this is what we need in Web3 right now. There's a lot of complexity involved with kind of switching platforms and going from essentially a monolithic chain to an app chain, and we need to make this a little bit easier. And so a lot of people talk about kind of modularity and modular infrastructure, and how does that fit into this kind of paradigm? Let's kind of talk about that, right? So is modularity the answer to this? And short answer is not really, but I'll kind of dive a little bit deeper into why that is. So here is traditional modularity, right? So generally in a monolithic chain, the DA, consensus, settlement, and execution are all performed by the same layer one protocol, essentially. And what modularity talks about is, hey, let's split off different parts of this, essentially, and have different parts of it handled by different sets of people, essentially, making it a little bit more scalable, right? Let me introduce, actually, what's called a modularity grid. And this is not something that most people kind of think about, but essentially, let's divide the verticality out into application and kind of security and infrastructure side. So in this grid, essentially, let's start using the examples of some of the chains that we have today, right? So in a monolithic layer one, how does it work? So when deploying on a layer one, the layer one handles all of the DA, consensus, settlement, and execution. And it's really great because they handle all of the security and infrastructure for you, right? It's easy to deploy because the L1 handles all of the security. However, everyone is sharing everything, right? So it's really hard to scale. So this is kind of like the problem with deploying on a layer one. What about an app chain, right? So here's an app chain example. It's like, hey, cool. Now everybody gets their own kind of full stack, essentially, which is great. But it's really hard to stand up the security infrastructure on yourself, right? So what does the modular kind of solution do? So in the modular world, people kind of think about it and you slice it like vertically, right? So in the case of ETH, DA, consensus, and settlement is handled by Ethereum, and then rollups and L2s are kind of doing the execution side of it. In Celestia, the slice is slightly different where it's sliced, but it's pretty much the same thing, right? You vertically kind of slice some portion of it, and you have the base layer handle one side of it, and the rollup and the layer two essentially handle the rest of it. So going to a layer two, so deploying on a layer two, essentially, everything to the left of settlement essentially is handled by ETH, which is great. So now you go to an execution layer and say, hey, look, I want to go and deploy on a layer two. What happens? It's great. It's easy to deploy because the layer two handles the security of the execution side of things, right? However, what ends up happening is you kind of run into the same situation where it's kind of difficult to scale because everyone is sharing that execution environment, right? So now you kind of think about, hey, how can we solve this situation? What other alternatives are there? People talk about ZK. ZK kind of fits similarly to how most other modularity system works. So if you take a look at this, the security and the infrastructure side is kind of handled by the ZK cryptography, but the execution side is pretty similar. It's pretty expensive to do. So there's no real app chain solution. So everyone is kind of sharing the same infrastructure. So you run into the same kind of bottlenecks that you have essentially with layer ones and app chains, essentially. So now, another alternative now is to build your own rollup, right? So launch your own rollup. Why don't you do that? So it's the same thing. It's like, oh, it's great. I get my own execution environment, so it's more scalable. However, it's kind of difficult to actually get the security and the infrastructure right correctly, right? You can make single sequencer products, but that's not really decentralized, right? So you can try to kind of stand up a decentralized set of sequencers, but then now you kind of run into the same situation as the app chains where it's kind of difficult to stand up, right? So let's go back to this little diagram that we had and talk about modularity and see how it fits in. So deploying on layer two, it's easy to deploy. It's affordable in the beginning, but it gets technically difficult to scale and economically difficult to scale. Now you go to build your own rollup, and it's kind of like the same story, right? And you still have this technology chasm. You haven't solved anything. You just kind of kicked the can down the road and said, hey, I'm going to handle this bundle here, but like now you have to handle this smaller chunk, but you still have to handle it ultimately. So the big problem with the modularity framework in my mind is that they run into the exact same trade-offs essentially. So you can deploy on a layer one, you can deploy on a layer two, it has the same number of trade-offs. You can deploy app chain as a service, or you can deploy rollups as a service, and you kind of run into the same trade-offs. You can build your own app chain, or you can build your own rollups. It's kind of the same thing, right? So we haven't really solved any of the problems that we were seeing essentially. So the current modular solution do not address really this developer problem. It solves other things. It's great, but it doesn't actually solve the developer issue ultimately for Web3. So what is the actual issue here, right? The reason it doesn't solve the issue is that the problem is not vertical, right? The problem is the developers don't want to share that slice up on top with other developers, and they don't want to stand up the actual infrastructure themselves. This is the issue. It's a horizontal issue. It's not a vertical issue, ultimately. So this is kind of where Saga comes in, and this is, I guess, where a little bit of the shilling starts. But essentially, we're a platform that solves the security layer of it and allows developers to launch application chains kind of easily. So what is Saga? Saga is a protocol for permissionless, automated, and secure application deployment. So essentially, it's a chain to launch chains. And what the protocol ultimately does is it handles the entire security layer at the bottom here. And it allows applications to have their own dedicated block space, kind of in the same way that if you just went and made a transaction and said, hey, deploy a chain for me, within a few seconds, a new chain will be essentially instantiated. So what does the Saga mainnet do? Saga mainnet, essentially, all it does is it receives transactions for deploying new chains. That's really all it does. It's written using Cosmos SDK and Tendermint Core. And everything that Saga does is interoperable using IBC, as Josh mentioned earlier from Osmosis. And Saga Chain supports launching, upgrading, and terminating chainlets, essentially. And what are these chainlets? A chainlet is a single tenant VM blockchain. And it can be kind of any blockchain that you want, as long as it speaks IBC and as long as it speaks essentially our shared security language, essentially. And so we have pluggable support for many different kinds of technologies, including different VMs, different consensus algorithms, et cetera. So essentially, in the mainnet, you can kind of have a checkbox and say, hey, I want a Cosmos chain that's EVM compatible and with these kinds of services, and it will kind of automatically launch that. Or you can say, hey, I want a Polygon supernet and with these kind of parameters, and it will kind of launch that automatically as well. So we have various partnerships, essentially, that allows the launching of chainlets. Saga also supports traditional modularity. So as mentioned, you can kind of slice the verticality whatever way you want based on the needs of the developers. So the big thing is that Saga kind of handles the security and infrastructure layer at the bottom. And so they don't have to, the developer doesn't have to worry about any of that. And then they can slice the actual application layer whichever way they want ultimately. So, so Saga is essentially one of the first end-to-end Web3 platforms. This is what we're trying to build. There's some kind of characteristics that we'll talk about. We have a testnet. If anybody want to test it out, come talk to me. There's some really interesting behaviors about horizontal scalability that you get with a design like Saga. So we're happy to talk about that. And we have a lot of innovators. So if you're a builder, essentially come talk to us. We'll love to get you essentially access to our testnet and get developing on Saga ultimately. That's it.